Calculus! This is AP Calculus. All right, so 10-3, last lesson. Again, here's our guide. We are in our last lesson, then we have a bunch of self-checks, pre-test, fix-up, test. All right, so the general absolute extrema. So let's talk about the parts of an integral. So let's assume that this is called f of x. F of x. That is the name of our function. Let's go and look at, I don't know, some random point. We're going to define our integral from a to b. So from a to, I don't know, let's do b at the very end over here. So if I'm looking at the integral from a to b, where will I have, and if I'm talking about integral, again, I'm talking about area underneath the curve between the x-axis and the curve. Where am I going to have a local, or I guess a relative maximum? Maximum of an area.
It would be like right there. Right there.
Right there. So I guess that's technically a relative, yes, you're right. So it's a relative maximum of f of x, but not of the integral of f of x. There's two different things I'm talking about here. So if I'm just talking about f of x, yes, this is a relative max of f of x. So let's say that this comes down here and plots onto, let's just call it c. So this is a local max of f of x. And another name for local max is a relative max, so relative max. And where on f of x will I have a relative minimum?
Looks like x equals 0.
X equals 0, yep. And that's technically outside of our bound, but we can go ahead and say that, yeah, that is a relative min.
Oh, then the relative minimum would be like over there between b and c.
Exactly. So that's not on a comma b, so we can't use that one, but we can use this one. This one is going to be a relative min, or a local min. Of f of x. And that happens here at a second point. We'll call it C2. That means that one has to be called C1. And if I'm looking at the position A and B, I'm going to do it in a different color. That's at this point and this point. So if I'm only looking at an integral, I do actually have to look at those endpoints. I have to consider them to be local mins and max. And this is a bit of a review. We always remember when we set up our table and we're trying to find the maximum or minimum of the value, always have the start point, the end point, and then any CVs. And CVs are dictated by if it's a local max or a local min, right? This is all review so far. Are there any questions up to this point? All right, so what I want you to do now is to draw some function where the absolute minima is at the leftmost endpoint. An absolute minima means that is the lowest value on the entire curve. And I'll show you what I mean by that in a sec, but I want all three of us, I guess I'm included, all four of us to draw an absolute minimum at the left endpoint. What does that function look like? Go ahead and do that now. I want to see what you guys come up with. Be as creative as possible. And it has to be a function, so it can't be in a function not defined in polar coordinates because we're not in BC math. So don't do any circles like that. No cardioids. What do you guys got? All right, Ben has a very simple graph. Not as creative as I was hoping for, but it is all correct.
What were you hoping for, like swirls?
Yeah, so here's something. I can have a point here. Actually, I should do it in blue. Point here could go up, it could come down, it could come back up. That's a little bit more creative because I technically have a local minimum right here. That's a local minimum, but I'm looking for the absolute minima at the leftmost endpoint, so this one works. So again, yours doesn't have to be as creative as mine. Every single one of you has a good graph as long as you make sure that you really have a point here. I know the arrow didn't have a point and just left it as a line. That's fine, but to make it...
At this line, but the other side was...
Oh, the other side went on? Okay, never mind. That one's good. Yeah, so that one can go on and on forever. But you do have to have a point on the leftmost endpoint, so you had that good. All right, try one with the rightmost endpoint. See how creative you can be.
So, for endpoints, at least one has to have it, and the other can be either an endpoint as well or an arrow.
Exactly, yeah. Do something creative. It has to be, we'll make this contingency, it has to be continuous, but it doesn't have to be differentiable everywhere. draw a continuous function, not necessarily differentiable, that has a rightmost endpoint for the absolute minimum. What do you guys get? How creative are we? Hey, Ben's got some sharp corners. Lots of curves. I like it, yeah. What am I going to do to be creative? I'm going to do rightmost endpoint. I'm going to do some sharp corners. I like Ben's idea. And I also like arrows, or arrow simplicity, I guess I do like. But I was thinking more of Rochelle's step function. So I'm going to do rightmost endpoint. I'm going to go like this. Chung, 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 chung. Rightmost endpoint. That is the absolute minimum. All right. Now you can be even more creative. I'm broadening your horizons. So neither endpoint has an absolute minimum. What is that going to look like? Show me what you got. Reference for Rochelle. So show me what you got. Yep. Ooh, so this is a cool case. I want to talk about this, but you're wrong. I want to talk about it though. It's super fun. Make sure that this ends a little bit above all the ones.
What about a vertical line?
Okay, so let's talk about both of those. So before I give you the answer, I want to talk about Rochelle's line. Rochelle's line was like this. It was a perfectly horizontal line. If I come back and use technology to make this a perfect horizontal line, that was Rochelle's graph. So technically, I guess it's more of a philosophy question. So the endpoint has the same y-coordinates, so technically this is an absolute minimum and an absolute maximum. This is an absolute minimum and an absolute maximum. This is a minimax. This is a minimax. Technically every point on here is a min and a max. So you did not get it correct because technically the endpoints are the absolute minimum. So it's a cool graph. And then Arrow was asking about a vertical line. Is that correct?
Yeah.
So if you have a vertical line, why is that not okay?
Oh, because an x can have more than one y. Y axis.
So it doesn't pass the vertical line.
Yeah.
Because it's not a function.
It
Yeah.
doesn't pass the vertical line test. It is a vertical line.
No, that's the whole point of a vertical line test is, yeah, you can't do that. So, yeah, arrows was not a function, not even a continuous function, because it's not even a function.
So then what's the answer?
The answer was, well, one answer is you can do arrows parabola. That's perfect. The absolute minima here, if I technically have to have endpoints. I can just go on and on forever with no endpoints. This is an example because the absolute minima happens right there. It happens at some C value in between A and B. The one note that I'll make for this one is, actually, yeah, that's fine. So the absolute minimum happens at point C. So we should add to our notes too. Let's circle the absolute minimum so it's easier for us to see it. So absolute minimum was there, there, and there. Let's do absolute maximum. So the left endpoint and right endpoint, there's not too much that I can do new to be fancy. Let's assume that we have a continuous function again for both left endpoint, right endpoint. Be slightly creative. It doesn't have to be too creative. But I really want you to think about neither endpoint again. Do something that's not a parabola and try to be creative for the neither endpoint. So we're doing all three of these now. Spend most of your time on neither endpoint. I want to see how creative you can be with this one. And I will silently do these up on the board. How can I do a leftmost endpoint that is the absolute maximum? I'm probably going to do one that looks like this where it doesn't have an endpoint. That's my idea for leftmost endpoint. Rightmost endpoint, what am I thinking? Not a whole lot of options left. I'm going to do, I think I saw Ben do one like this, where he did rightmost endpoint and then he kind of went down, down, down. So there's my rightmost endpoint. Again, I'm circling the absolute maximum, and it has to be absolute. So absolute is like nothing else is higher than that point.
Wait a minute.
Yes. I'm going to cheat for my creativity. I'm not going to even have an absolute maximum.
Cheater.
And you can do that too if you want.
Why do you just not draw anything?
I have to draw something, but draw something that doesn't have an absolute maximum. Can you think of something? If you already drew a graph, you can draw over it again, or you can erase it.
Something with more than
like a sine wave function that just touches
that.
the same thing.
Technically, that does have an absolute maximum that just occurs at multiple points. Like, oh, okay, that's the philosophy question. Maybe you're right, maybe you're wrong. I would say there's technically multiple absolute maximum because they all have the absolute maximum is defined by. Oh, actually, I think it's defined by on the entire interval that it's defined. It has to be the highest point. So it doesn't. You're right. It doesn't have a maximum for a sine wave. So yeah, go ahead and draw a sine wave. That doesn't have any absolute maximum or any absolute minimum for that matter. What's another example where I don't have any absolute maximum? This is kind of fun to play around. Would you two come up with, Arrow and Rochelle? Same thing.
True then.
Okay, so I would say on this one, the absolute maximum.
Yeah, but it's not your endpoint, so.
Oh yeah, so you're just doing what it actually has. Yeah. Okay. Here is. Should I do the most simple answer? Are you ready for it?
Let me guess.
Yeah,
Is
guess.
it the line that I did for the neither endpoint of the minimum?
Nope.
Okay.
Wait, wouldn't that be correct because the definition of a maximum means there's only one,
Yeah, there's only one.
which means a flat line would be fine.
No, because the definition is it's not only that there's only one. It's that at that point there's no other point that is that height or above it. But there are other points that are at that height, so it can't be an
So
absolute
that-
maximum.
Oh. No, that would work for the neither endpoint graphs. You can just draw from it.
If you have endpoints, then those endpoints will be at the absolute maximum. So if you're not at an endpoint, then that is an endpoint. So that doesn't work.
Okay.
Here's my answer for neither endpoint. Let me change the color back here. This function that I'm about to draw right now doesn't have any endpoints, so the maximum can't occur at any of the endpoints. If you don't have endpoints, then you physically cannot have an absolute maximum at the endpoints. So this one doesn't have any absolute maximum either, just like your other graph. So Ben had the sine wave that kept going up and down. This one also satisfies the condition that it doesn't have any maximum at all, and that's because there aren't any endpoints. It continues up and up forever. It goes towards infinity. So if I were asking what is the absolute value or the absolute max, you'd say absolute max does not exist. All right, so that's fun. Let's go ahead and talk about the general setup. And this is, again, basically a review. So if I have a table and I want to find all the absolute extrema, again, I'm talking about absolute, not local, what are the things that I have to check? And I guess you'd have to check the local extrema too.
Wait, does general, absolute, extrema, general, and absolute like cancel? What?
So general means I'm going to be talking about letters instead of numbers.
Oh, okay.
Variables
Got
instead
it.
of numbers.
Yeah.
So my general table setup, again, is I'm going to look at my x or t values. I'm going to say my x values for this case. Let's assume that our function is with respect to x, and you're going to do start plus change is going to be equal to the end. All right, and this is really the key part of this lesson again, is reviewing what are the x values that I have to check. Where can a maximum or minimum occur? And look at your tables. Where did the maximum and minimum occur?
At the left endpoint, the right, or neither.
Right, so if my integral is defined between a and b, then a is going to be the start, b is going to be the end. So I need to check the start and the end. So I'll make a note here. This is the start. I can draw that a little bit bigger. This is the, whoa, too far. Oh, is my computer just like not liking me? Okay, whatever. A and B. A is going to be our start, and B is going to be our end. Start and end. What other values do I have to check?
Like horizontal asymptotes, or?
Any horizontal asymptotes, exactly. So I'm going to call that, maybe we have two of them, C1 and C2. Very similar to our graph up here, I'm going to do C1 and C2. Those represent some x values. Maybe I should do x1 and x2. Some x values that have a horizontal asymptote. So this is where, and the way to abbreviate that is where f prime is equal to 0. I'll do that in yellow to match with our other notes. This is where f prime was equal to 0 for both of these. And then everything else is as follows from before, so nothing new here. Assume that you're starting at some general value of a, so f of a at that point. F of a for all of these, because we're all starting from the same general value of a. And then I'm going to add to each of these, well, nothing here, so just leave that blank, because it's going to be from a to a. We don't care about him. This integral is going to be from where to where?
From A to B.
A to C1.
A to C1. Yep, A to C1, and then let's pretend that we were dealing with f of x. So f, and since we're always in this unit are talking about some rate, I'm going to do f prime of x. What is the total accumulation that happens between a and the value of C1? And then similar integrals down here between a and C2, the integral between a and b of f prime of x, f prime of x. All of these are with respect to x, dx, 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 and that will equal some value. What is that value, by the way? If we're keeping it general, which is hard to do in mathematics because it means you have to really think about what's going on, what is this value? What is the short notation? What did I just find? This is f of a. Therefore, this is
F of A plus C1. F of C1.
f of C1, yeah, there it is. That's the general value. I found the position at C1 by taking the derivative of f of x, finding the accumulation that happens, and that is the total position change, and I get total position change plus start to get that value. And then all of these follow with Rochelle's logic, f of C2 and f of b.
So, but that would just be the height of B.
Yeah, it could be the height of b. It depends on the interpretation of the problem. If you're looking at a graph, it's the height.
What about, yeah, but what if you just have a weird start value?
A weird start value, such as what?
What if, what if you started at like, but f of A is a y value too, that's very interesting.
So I think I hear what you're saying, like, what if, and this will happen to you, what if I have f of a here, and then one of the values I have to check is right here at C3? Right? That would be a weird value, because outside of your, it's before your start value. It will happen.
No, but like
They-
in the context of the problem, say if you were counting like number of chipmunks or something, and you already have like 10 chipmunks that aren't represented in the graph, which would be the A value? Wait,
They'll
that's different.
so I think you might have answered it yourself. But they'll tell you what that value is, and you just need to remember to add it. And it should match up with the graph. If it doesn't match up with the graph, something has gone terribly wrong.
Now I'm confused about what f of A is, because I was pretty sure that was the predetermined value.
It should be a predetermined value. It should be this height. F of a is this height.
Okay.
But let me follow down this road, this tangent. What if I have C3 to be right there? How would I do that on the table, if we can squeeze that in here?
Would it be C3 before A?
Oh,
Or never mind.
So it's still going to be f of a plus, but this integral is going to be all weird.
it would be minus
Yeah.
C3 to A.
Yeah, so it's minus the integral from C3 to a.
Wait, it's minus? I thought it was a negative.
Oh.
Yeah, well,
So why is it minus C3 to a?
it's because the lower one has to be on the bottom of the integral.
No,
Yeah.
I see why it's like that, but
Oh.
it's just the way that you told us last time. I thought it was a negative.
What is a negative?
When it's like,
Oh yeah, like this negative symbol right here?
yeah.
Yeah, so get rid of the plus, it's just a minus.
Oh,
F of a minus this integral of f prime of x dx. And that will give you the position at f of C3.
wouldn't it be negative F?
No, it's just the position at C3.
Oh.
Because you'll start here, and then whatever change you get, you subtract that change. And that makes sense for the graph. So if I start here, I find the change is always a positive number, and then I subtract that. Technically, if you plug it into your calculator knows how to switch these bounds. So if you just do f of a plus a to C3, it'll automatically switch that, so you don't have to rearrange the formula if you don't want to. Your calculator is smart enough to know what's going on. Well, technically, it'll just be a negative integral, but that's a story for another time. Yeah. All right, so that's all I have for us today. Any questions? General values? All right, good review. That's it.